When performing calculations in chemistry, it is important to maintain a degree of certainty by reporting values with the correct number of significant figures. Occasionally, a calculated value may include numbers that are not significant figures. In order to report an answer with the correct number of significant figures, the answer needs to be rounded up. The first rule for rounding calculated values is if the first digit that is not included in the final answer is greater than 5, the digit before it will be rounded up. For example, if the calculated value, 3.127 grams, should have only 3 significant figures, the number 7 determines if 2 is rounded up. Since 7 is greater than 5, the number 2 should be rounded up to 3, which results in an answer of 3.13 grams. The second rule for rounding calculated values is if the first digit that is not included in the final answer is less than 5, the digit before it will remain the same. Say if the calculated value 10.627 milliliters should have only 3 significant figures, the number 2 will determine if 6 is rounded up. Since 2 is less than 5, the 6 is not rounded up and the final answer is 10.6 milliliters. Now that we have reviewed the rules for rounding, let's work through a couple practice problems. Please pause the tutorial and determine which answer is correct. When 18.248 is rounded to 3 significant figures, the first significant figure is located in the tens place, the second in the ones place, and the third in the tenths place. Although the numbers 4 and 8 are not included in the final answer, the number 4 is still important. The number 4 is important because it determines if 2 is rounded up. Recall the rules for rounding. If the first digit that is not included in the final answer is less than 5, the digit before it remains the same. Since 4 is less than 5, the 2 is not rounded up, resulting in option B, 18.2, to be the correct answer. A common error is rounding multiple times. For example, it is incorrect to round the number 4 to 5 due to the number 8. This would then cause the 2 to be rounded up to 3 due to the new number 5. Multiple rounding is sometimes called the domino effect, which can lead to large rounding errors. Keep in mind that only the first digit that is not included in the final answer affects the rounding of the last significant figure. Let's take a look at the first option. This is not the correct answer because the answer should be expressed using 3 significant digits. A common error is that the rules for determining significant figures only apply to decimals. This is not true. Rules for determining significant figures apply to the entire number, not just the decimal portion. Now that option A is eliminated, let's write 14.985 using 3 significant figures. The numbers 1, 4, and 9 are included in the answer. Although the numbers 8 and 5 are not included, the number 8 is still important because it determines if 9 will be rounded up. Since 8 is greater than 5, the number 9 will be rounded up to 10. The 10 can be thought of as a 1 and a 0, the 0 in the tenths place, and the 1 is added to the ones place. The 1 is added to the 4, which results in 14 becoming 15. Another way to look at this number is breaking up 14.985 as 14.000 and 0.985. The 8 that is located in the hundreds place will cause the 9 to be rounded up to 10, resulting in 1.0. Therefore, option C is the correct answer. When 14,751 is expressed using 3 significant figures, the numbers located in the 10,000s place, the thousands place, and the hundreds place are included in the final answer. Although the numbers 5 and 1 are not included in the answer, the number 5 is still important because it causes the 7 to be rounded up to 8. Therefore, the numbers 1, 4, and 8 are included in the answer, resulting in option B to be incorrect. Option A is clearly not the correct answer because 148 is significantly less than the original number. Although option C has 3 significant figures, the zeros in this value are ambiguous because there is no information regarding the measuring device used. Therefore, these zeros may or may not be significant. By writing this value in scientific notation, the ambiguous digits are removed and there are 3 significant figures expressed. Therefore, option D is the correct answer.